That's going. The registration form is posted on the chat. So let's go. Okay. Evening, guys. Today or tonight or this afternoon, we're starting with chapter 8. So we're starting to look at confidence intervals. You basically need to do 3 things. So I'm gonna take this one out. You basically need to do 3 things with confidence intervals. Um, you're gonna look at, and you will probably get these 3 as 3 questions in the exam as well. So what you will get is the one that we will first look at is your population mean when your standard deviation is known. That you will work out with Z values and things like that. Then the second one is when your population mean is unknown or not known. So they normally, with that one, can tell you straight in a question that your population mean is unknown, or they would reference in the question that you're looking at the sample mean. But we'll get to that. For working out whether population mean is unknown or your standard deviation is unknown, we will look at a new variable called the t-stat, and we'll look at the t-distribution for that. And then the last one or the third one in your confidence intervals is when we will look at the population proportion. So remember in study unit 6 or 7, we also looked at population proportions. So now we will just bring that into account in interval estimation as well. And for interval estimation for population proportion, we will also use a Z. So I think just important, if it's known, we will use a Z. If it's unknown, we will go to a T table, and with population proportion, we will always look at the Z. So the one that they would try to catch you out with in the exam is between these two. Okay, so that is normally where they would try to catch you out. Okay, in this pack is also a lot of definitions and formulas in, so that you have everything together again. So basically what we're gonna do every time. So we're gonna, if we have the X, we're gonna every time nearly subtract or plus a margin of error. Okay, so that is what we're gonna do the whole time. So later on, when we get to some of the questions, what I will also show you nearly in each of them is also a way of looking at some of the answers by just looking at this formula and starting to eliminate some of the options. But basically, what we're going to do is every time we're going to work out a margin of error. You will, as we go through the chapter, the things that you will pick up is that we talk about a 90%, a 99%, 95%. So those things will be standard kind of percentages. In the exam, it will always be 90, 95, or 99%. You, in your study guide, there's also a table that is a reference to that. I will just check what the page is. But tonight I'll send you some other summary pages that I have made that is on as well. So in the assignment, it might be that they give you a different level of confidence just to see if you might be able to use one of the tables or online calculators, but definitely in the exam, we will always only look at 90, 95, and 99% confidence intervals. Okay, then if that is basically what I already showed. So when we know what the population mean is, now you will remember this diagram nearly from, I started showing it to you in study unit 6, where we know the mean is in the middle. So what we will also learn in this study unit is there might be references to a one-tail or a two-tail. So in this instance here, we have a two-tail because there's one tail there, there's two tail there. So the only time when there's a two-tail, and we'll see that in hypothesis testing, is when we do something that is equal to or not equal to. The one tail and two tail, we will basically use mostly in hypothesis testing, that is in chapter 9. So again, this chapter is important for the next chapter, because that will be where we will say, okay, if it was a 95% confidence interval, we will say within that 95% confidence interval, around the mean, this is what the values will be, and we will then use the Z tables to work out those values. Okay. Then the other thing is how we look at the formula. So basically, remember again in study unit 7, we looked at the standard error. So basically, it is your sample mean, and then it's plus and minus because we will need to get. So if that is your sample mean, we'll minus it by the margin of error so that we can get a value that is smaller than the mean. Let's call it x1, and then we will add again to the mean so that we can get a value that is bigger than the mean. Okay, so that will be your two then confidence, the lower confidence and the upper confidence levels. Okay, so for when the standard deviation is known, we use this formula. We need to look at the Z. We'll get the Z. I'll show you how we get to the Z values. And then they must give you the standard deviation and your sample size. Okay, then we go into the one where it is unknown. So where it's unknown, and here you can see they would normally say to you your sample standard deviation. So instead of using the word population, they would use the word sample. Then you know that your standard deviation is unknown. Standard deviation unknown, we're going to use the t-distribution. I just quickly want to open up the study guide to show you also the t-distribution, where that is in your study guide. Let me just get that. Just looking for it in my folders. This is what I find. It's supposed to be. Okay, so we had the Z tables. So we will have the t distribution table 4 in your study guide. So it's around page 134, 135 in the study guides. What you will see is they give you two things in the t table. They give you the level of significance. Remember that level of significance is only looking at the one side, and then they give you degrees of freedom. So normally how you work out the degrees of freedom, and hopefully there is a formula. Just want to check if I don't say it. So how you work out the degrees of freedom is just to say n minus 1. So they need to tell you how big the sample is. So if I tell you the sample is 50, your degrees of freedom will be 50 minus 1, which will give you 29. Okay, so they need to give you that. And then, so if we go down to 29, obviously we'll see a few variables or few answers, but then I also need to tell you your level of significance. So let's see if we have it in here. Otherwise, I will need to bring that into the discussion as well. Okay, so they don't give it here. They tell us about it. So the one thing that we need to add here is that we need to talk about the level of significance. So it will look like that. So they can, again, in an example, can give you that sign. They can say level of significance, or they can talk about your confidence interval. So there's a few things that they can talk about. Your level of confidence is basically 1 minus that. So we will, when we talk about a 95% level of confidence or confidence interval, I'll show you how we will get to what it's needed to get that into that space of there. So I'll show you now when we get to one of the exercises how we will get to using this table. Okay, and then very similar formula for when the population mean is unknown or the standard deviation is unknown. So you will see the x is still the same, your mean. You have a sample standard deviation instead of a population. So basically very similar. The only thing that is different is that we talk here and use the T instead of a Z. So what the problem is that you will encounter in your assignments and in your tests or your exam at the end of the year is, unfortunately, they would give you an answer that if you worked with a Z, you will get one of the answers. So, and you will also see as you now prepare for the next assignment that if you use the T or you use the Z, some of the answers are very close to one another. So that can also happen if you have a big N, and this is nearly what I wanted to show you here. If you have a big N, your degrees of freedom, you will see that you get close to all the numbers that are nearly on the normal distribution. So if you sit with a sample of 100, you can see how close it is to what you would have used if it was looking at the normal distribution and the Z value. So this is one of the big things that they will try to catch you out in both the assignment and the exam. What will happen again in the assignment is, I think Ian or Peter talked about it last time as well, is if you've done it, used the T and you should have used the Z, you will probably get again 1 or 2 marks out of 4. The same if you used a Z and it should have been a T, you would probably again get 1 or 2 marks out of 4. So again, in the assignments, they will just not mark it wrong. You will get some points at least. Okay, so what I always find easier to, and again, you can print this out, you can keep it as a slide or something at hand, is when I go through a question, I automatically first look at what is the standard deviation. If it's population, it's known. And then I can use the normal distribution. If I don't see any wording of population, or if I see that they talk about sample, then I look at it and I say, okay, well, it's not known. In that case, I will work with a T. So again, if you have access to a printer, please, if it will assist you, nearly print this slide so that when we get to those examples, that it's easier for you to look at. Okay, and then the last one is when we look at the population proportion. So very similar is that they will talk about the proportion, and you will need to add or subtract the margin of error. And in this instance, again, when we looked at what was it, chapter 7, or was it 6 that we had the standard error for the proportion. So again, we will use that standard error in the formula. So it will be the proportion, it will be the standard error component, and then we will multiply that standard error with a Z value. Okay, so that is nearly the three things that we will cover tonight is work out a confidence interval. There's basically three confidence intervals that we will work with. It is when your standard deviation is known, when your standard deviation of the mean is unknown, and when you are working with a population proportion. Okay, and you will see that with your population proportion or with your proportion, there's only one. So again, when they use it in the assignments or the exam, if they use population proportion or sample proportion, it doesn't matter. It's only when it is with the mean that unknown that it matters. Okay, so I think this is just a quick summary of each one. So the ones that we will work with is 95 or a 90 or 99. And instead of just showing the table, I will send that tonight. But the Z values that's linked to this is in that table is when we look at 90%, it is 1,645. When it is 95%, it's 1,96. And when we look at your 99% confidence interval, it is 2,58. Let me quickly show you while I have it open. Let's just quickly show you what table I am referring to. To check if it is in. So this table, so in the 1610, just around page 1558, I will check what it is in 1510 as well. But this is the table, so you can see that's where I got the 99, 95, and the 90%. And this is what you will use every time when you're looking at confidence intervals. Confidence intervals is always two-tailed. So that is why you can use them without needing to show how you got there. It's a given fact that those are the three numbers, so you can use them. The only time that we will need to nearly look for something is when it's a t-distribution. So I'm just moving back to the t when we need to use that. Okay, so also in this pack is just again the looking at the confidence interval of the means and the confidence interval of a proportion. So basically we have three things that they can ask you in the exam on chapter 8 if they don't ask you any of the definitions or theory. Okay, so let's start with the first question that I've put in the presentation. A statistic practitioner took a random sample of 50 observations from a population with a standard deviation of 25. Okay, so is that standard deviation known or unknown? What would you say? Is it known or unknown?
It is known because it's given.
Perfect. Okay, it's known. We work with a T. Ah, it's known. We work with a Z. We work with a 95% confidence interval. 95 we said is 1,96. Okay, so that nearly it makes it when we do the calculation also a bit easier, because now you've nearly said, okay, population standard deviation is known. Because it's known, I'm working with a Z. Because it's 95, it must be the Z of 1,96. Okay, so then let's just write the original formula out. Later on, I will not write the Z. I will just say what the numbers is. But now you will see, okay, so we've got the Z that is 1,96. That's fine. We've got the standard deviation, which is 25. We've got the mean, or sample mean, sorry, the sample size is 50. And we've got that mean of 100. So we know what that mean is as well. Okay, so before I even look at these numbers, I said I wanted to show this to you. So whatever we subtract is the same value that we will add as well. So your 100 will be in the middle. On the top end, there will be something bigger than 100. And on the bottom end, there will be something smaller than 100. Okay, so you will have smaller than 100, bigger than 100, 100 in the middle. Okay, so when I look at these answers, I'm like, okay, something smaller, something bigger might be that. 100 on the dot, okay, so it can't be that. 6 points, so this is just something wrong in that answer totally. You can't have such a small. That is probably looking at that answer that was calculated, but let's just look at others. So 9.31, okay. 10 points, so again, something here went wrong. Your midpoint is 100, so that number should be bigger than 100. It's not. So again, one that we can cancel out. Then we look at, okay, 94 is right. It's smaller, 105. Okay, so that can also be one of the answers. And then the last one, sure, if that 100 should be in the middle. So if I put 100 in the middle, it's only 6.9 to the one side, nearly 60 to the other side. So that 100 would not be in the middle. So that one I can also cancel out. So by just merely looking at a simple way of putting my 100 in the middle, because whatever I'm going to add and subtract is going to be on both sides, I actually just got two now to worry about. So again, if if you in the exam situation, to guess between 2 and to guess between 5, yeah, the odds is becoming much better. If you have it in your assignments, this what will probably be is the one with a Z will be the one, and the one with a T will be the other one. So at least you will get points without actually working out anything. You just cancelled out things that just didn't make sense. Okay, so let's quickly work it out. It is 100 plus minus. So if I take 25 divided by the square root of 50, I'll multiply that answer by 1.96. I actually get the 6296. Okay, so I was hoping this didn't happen, but I'm using a different screen tonight, and it is obviously not still giving me the same errors with my screen. Okay, so what actually happened is they give us the 100 and they give us the second part of that sum. So sometimes if something looks weird, it might be giving you a hint as well. So if I say 100 minus that, we will get 93.07. And if I say 100 plus that, we will get 106.93, which is then option 1. Okay, so basically the first thing that we did is to identify if the standard deviation is known or not. If it is known, we know that we can work with a Z. A Z95, we know from that table in the study guide is 1.96. So we have the Z sorted out. Then we just complete the rest of that formula and work out the rest of the question. Okay, is that making sense? If you're now looking at this for the first time nearly, does it make sense? Okay, cool. Okay, so let's look at the next one. So look at what they tell us from the information given below. Determine the 95 confidence interval of the population mean. Give you that, they give you that, they give you that. Okay, what is S? Is it standard deviation of sample or standard deviation of mean? Now we go back to chapter 1, where we did all the signs and those things. And I always said S goes with sample. Okay, so here we've got sample standard deviation. Sample standard deviation, we work with a T. Okay, so I've now added, let's that out. Okay, so work with a T. Let's just go and see what is the formula for the T. I want to quickly just put this in for you so that you I'm not working with the wrong one. Interesting, it doesn't want me to do this now, what I wanted to do. Okay, so let's just take it there and then I will delete it again. Okay, so the formula that we're looking at, we're going to work with a T. The N minus 1 is degrees of freedom. So I normally do is I just write degrees of freedom. And we work with alpha divided by 2. So that is the T that we work with. And we multiply it by the standard deviation divided by N. Okay, so that's with the formula that we are working with. Okay, so 200 is your X, I give it straight to you, plus minus standard deviation is 5 divided by square root of 100, which is going to be 10. Okay, so now degrees of freedom. So degrees of freedom is equal to N minus 1. We know N is 100. N minus 1 is then 99. So we've got that. And then what we will see as well is that we need to get for alpha divided by 2. So for alpha divided by 2, it is basically 1 minus the confidence interval. Divided by 2. So that alpha is the same to say 1 minus the confidence interval that they give us. So 1 minus 0.95 is 5%. So 5% divided by 2. So just look at the 0.05, which is 0.025. Okay, so we're going to look for a T that is degrees of freedom 99 and alpha that is 0.025. Okay, so let's 99, 99, 99, 99. Okay, so again, in the exam, you will, that number, the T number will be on this table. You will not now get a T that is 150. If you get a T that is 150, you can assume that it is actually a normal distribution and use the normal distribution numbers. We're working with 99 and we're working with 0.025. So we have a number of 1.984. Okay, so 1.984. Okay, so let's see, interesting. So let's go through the set again with the idea of 200 being in the middle. Bigger 200, smaller 200. Okay, smaller 200, perfect, works. Smaller, that must be bigger than 200. It's not. Option 1, it is not. Okay, smaller than 200, yes. Bigger than 200, yes, but sure, that gap is big. Remember that the 200 must be in the middle. Here it is only 1.92 bigger, and there it is like 91. So the chances that that is also correct is very slim. 200, 0.992, also not correct. 198, 209. So again, if 200 is in the middle, we actually have 9 to that side, 2 to that side, so that is also wrong. So option 3 will be your correct answer. But let's work it out. It is 200 plus minus, so 5 divided by square root of 100 is 5 divided by 10, which is a half. So it's a half of 1,984, which is equal to 0,992. So the biggest side is 200.992, and the smaller side is 200 minus that, which will give you the 199.008. So again, just saying that is correct. So 200 minus 0.992 would have given us 199.008. And then the 200 plus, that would have given us 200.992. Okay, so with this one, they didn't tell us unknown or known, but they've given us in the symbol that they're using for your standard deviation. They've given us the clue that it is a sample standard deviation that we're working with. Okay, so we've done one with population known. We've done one with population unknown. So another one, and let's see what they tell us. A random sample of 25 was drawn from a normal distribution with population standard deviation of 5. To check that it's not the same question. Okay, so population standard deviation. So we know it is when known. If it's known, we work with a Z. First thing then I look for is in my sentence, what is my confidence interval? They tell me it's 99, 95, so I know my Z is 1,96. Okay, so we work with the sample mean of 80. So again, I would do this just again. 80 in the middle, smaller, bigger. 80 in the middle, smaller, bigger, can work. 80 in the middle, smaller, bigger, can work. 80 in the middle, can't work. That is probably going to be the one that I plus or minus, but let's see. 80 in the middle, can work. Okay, totally wrong because it is in the thousands. I nearly wanted to say 7804, 78.04. I would have gone with option 1 as, but so we've got 3 options that we are working with. Okay, so what we then need to work with is what is your Z times standard deviation. They tell us it's 5 divided by the square root of n, which is divided by the square root of 25. So that will turn into 5. So 5 divided by 5 will be 1. So we will work with 80 plus minus 1,96. My top one will be 81.96, which is that. My bottom one will then be 78.04. Close. Those two were owned, both of them. So that was just swapped around. There's your not 78.04. Okay, so that would have been your answer. So again, we've now worked with population standard deviation, so we know it's known. If it's known, we can use the Z. They tell us 95%. 95 is 1,96, and then we just need to work out the margin of error component. Okay, so I'm hoping this tip around how to use the mean within this confidence interval is helping, because it can assist you in narrowing down some of your answers. Okay, let's look at another one. So let's see what a simple random sample collected from a population of which is known. So I highlighted that, but this is which is known. That for population standards. So known, work with a Z. Then even before I do anything else, I want to look for what is the confidence interval. Again, I see it is 95. So I work with a Z that is 1,96. Okay, let's look at what the sample mean. Sample mean 240. So let's just, for starters, eliminate 240 in the middle. That one can work. 240 in the middle. So that is probably going to be the one that we need to subtract and add. But okay, so that can't be. 240 in the middle can be. 240 in the middle, sure, can be. 240 in the middle. The 2 is swapped around. So I would probably have gone for that one, because that is the one that's been swapped around, but it can also be one of the others. Okay, so at least now again, only dealing with 3 and not 5 options. Work it out. We sit with 1,96. You've got your sample of 50. You've got your standard deviation. So you need to multiply 10 divided by standard deviation of 50. Let me quickly just get Excel to work that out. So if I have 10 divided by square root of 50, that will be 1 comma, that will be 1,8925. So if I then multiply that by 1,96, I get the 3,5785, so 240 plus minus 3,5785. So on the top side, would add the two together. So on the top side will be 243,5785. Okay, so I would have guessed wrong if I needed to guess. It is that one. And on the bottom side, it will subtract, so it will be 236,4215. Okay, so I would have been caught out. I would have guessed it wrong. Okay, so option 1 is your final answer. But again, basically, in the sentence, they told us it's known. We know that we're working with Z. They tell us it's 95% confidence interval. Then we know the Z is 1,96. And then we just need to work out the margin of error component to it as well. Hopefully the last two is on proportions. So proportion, I've already added the formula. You have the formula, will have it in front of you. So again, please don't learn the formulas. I will see if I can just also, I'll just need to locate it on my PC, my previous formula list with no things on it. Okay, so let's see what they tell us. Random sample of 50 observation results in 50 successes. So you can work out that proportion will be 50 divided by 80. And so 50 divided by 80 is equal to 0,625. Okay, so just as with the mean, don't let this number, or because it's now a very small number, nearly put you off. It's still, that number is in the middle. So that will be the P that you are working with. So that is in the middle. So if you look at options, one should be higher than that, one should be lower. Okay, so it's not that one, higher, lower, so it could be that one. 6 to 2 is smaller, 6 to 5, sure, very close, so it can be that one. Higher, lower, can be that one. Lower, but also lower, so not that one. So at least we have eliminated 2, and by just again looking at the process of the mean must be in the middle of the 2 confidence levels. 95%, so again we can say with 95% that we are working with a Z that is equal to 1,96. Now we just need to work with that P. So again, I am going to add this into my Excel to work it out. Okay, so if I work that out, that is under the square root, so it's 0.625 times 1 minus that is 0.375 divided by n. I should have included what n is. N is 80. So if I just look at now what is underneath here, so just if you working it out as well, 0.0023 or 293. Okay, so I still need to take the square root of that. And then I still need to multiply it by 1.96. When I do that, I get that I need to plus or minus 0.1060, like that one. So 0.625 plus 106, 0.27731. And then on the lower end, it will be 0.519. Okay, so option 4 will be your correct one. So in that instance, I probably would have gone for that and guessed that one. But yeah, this is, so again, your mean is the P that they have given you by telling you what values you need to use. So that is in the middle. And then you work out your margin of error component by using this part. Again, because it's proportion is always a Z. So we could have, and with a 95%, we can then say automatically the Z is going to be 1.96. Okay. Okay, then the last one of the evening. So let's look at what they tell us. Okay, population proportion, Z, 95, so Z is 1.96. Okay, so that's the easiest. If you are on my WhatsApp group, I'm gonna post the recording on there, but else if you don't have my number or on WhatsApp, send me a WhatsApp later. I'll add you to the group. So just WhatsApp me on 0837908387. I'll add you to the group because I will put it somewhere on YouTube, but it will be later on available on the MyUNISA website as well as a link as one of at the Western Cape tutorial areas. It will be there as well, but please just send me a WhatsApp and I'll add you to the group and I'll share the link later on tonight. Okay, so cool. So the one thing that we need to work out is P. So let's look at what they give us. They tell us results consistent, showed that 46 out of 200 were not covered by insurance. So 46 out of 200. So if I look at what 46 out of 200 is 0.23. So there they give it to us, but obviously that again is not going to work that nicely. So 0.23 is in the middle. So let's look at options. Smaller than, bigger than, okay, can be. Not smaller than, so that's bigger, that's smaller, so it's definitely not that. It can't be just 0.23, so that is also not the option. That's bigger, it should be smaller. That's smaller, it should be bigger. Not that one. Smaller, bigger, so it can be this one as well. Okay, so we basically sitting with two options just again by eliminating how it should look like. Formula will be the, let me do that again. So it will be your P, so it is 0.23 plus minus a Z of 1.96. Then remember we've got the standard error that we need to work out. So it's 0.23 to P times 1 minus P. So it is 0.77. And that we divide by the sample size, which is 200. Okay, so again, easier for me just to use Excel for this again. And your calculator will do as well. So 0.23 times 0.77 to check that is correct, divided by 200 because that is your sample size, times 1.9. Then let me just check. 0.23 times 0.77 divided by 200 gives me 0.039. And if I then say that times 6, just hope it works out, I get 0.0583. So let's hope plus minus 0.0583. Let's hope there's an answer. So if I add it to the top side, it will be 0.2883. Okay, so that's very close. And to the, see there's that one as well. So it's probably rounding off. And then to the bottom side, it will be 0.1716. Okay, so by rounding off, and again, they won't give you 1.5 and 8.3 as an option as well. So definitely by rounding off, it was close enough, which will give you option 1. Okay, so, but again, firstly, identify it's a population proportion. Proportion, we always work with a Z. 95% 1,96. And then because of a proportion part, just remember that the margin of error is a bit different than the margin of error when we're working with the standard mean that we work with. Okay, so that is basically, if you look at from a calculation point of view, what you need to know for study unit 8 for confidence intervals. That's the 3 types of questions that they can ask. What they can do, and I think that is also just important, they can ask you, like we had in study unit 7, where they ask you to work out a standard error. Here they can ask you to work out that standard error or that margin of error, which is every time just, so if it is with an interval of a mean, that is your margin of error. So just remember, if I ask you margin of error, it includes the Z over T that you need to work with. So that is your margin of error. But if you're only looking at standard error, that is just your standard error. So again, just a bit of terminology, that it might be that they ask you in the assignment, work out the standard error when you know it's only that portion. But if you need to work out the margin of error, it is including the Z. The same with the proportion. If we're only looking at the standard error, will be that part. If we're looking at the margin of error, it will be that part. So just, I'm always, when specifically in stats, I'll sometimes, just by the terminology, they want to catch you out. So just be careful with between what we call standard error and what we call margin of error. Okay, is there anything else you guys want to ask tonight around this study unit? You can also, if there's from the previous work, and I now see that there's definitely 2 different timelines for 1510 and 1610, with focus on different study units, and different dates of when you need to submit and those things. But we will definitely try to still keep it aligned that you guys, doesn't matter which one you have, that we will cover the work before you need to write, or before the assignments are open. Okay. Any questions, anyone? And does it make a bit more sense after the session? Cool. Okay, then have a very good evening. We're not, I'm traveling again next week, so we're not going to have next week, but we will have a week after that. So the first week in August, we will definitely have a session on chapter 9. But not next week. Yes.
Hi, sorry, would this presentation and slides also be available?
Yes. So I think since you will only join the group tonight, I will post again. So what I'll do is you will see with that link that I'll send, there's also all the recordings of all the previous sessions is on there. And I will reshare all the previous slideshows as well. So no problem. All will be on the WhatsApp group as well. Cool. Okay, yeah. So just if anyone else, whenever you're watching this, and just remember you want to join the WhatsApp group, no issues. Just send me a WhatsApp, 0837908387. I'll add you to the group. Okay. Have a great evening, everyone. Stay warm and hope you have electricity. And then till next time.
Good night.
Thank you.
Sharp.